Now that we have practiced factoring, we're going to start simplifying rational expressions. So a rational expression is anything that is in form of a fraction. So if we look at our fractions, we are trying to simplify them. So our first fraction here, we can simplify our variables, we can simplify our numbers. So if we think about our variables, we have x squared over x squared. So that's going to eliminate. Now let's think about 90 over 63. So if we have 90 over 63, that can reduce, both of those can reduce by 9. So if we think about dividing both by 9, we'd have 10 and we'd have 7. And so our final answer here would be 10 over 7. So we're just reducing our fractions. So if we look at our second one, again, we have numbers that we can reduce. We also have variables that we can simplify. We have more x's on the top than the bottom. So remember your exponent rules. If you're dividing, you subtract your exponents and you put your answer where there were more. So we have 5 minus 2. That means that in the top, we're going to have our x cubed. And if we think about our numbers, 18 and 30 are both divisible by 6. So I would have 3 and 5. So 3x to the third over 5 is my simplified fraction. So when we have more than just monomials in our rational expressions, we are going to have to think about factoring in order to be able to reduce our fractions. So we're going to factor top and bottom, and remember to look for all forms of factoring. So we're looking for GCF, we're factoring trinomial. In the top, we do have a GCF of x, so we'll have x and x plus 3. And in the bottom, we have x and x. We're thinking about factors of 6 that will get us to 5. 6 is special because both 2 and 3, as well as 6 and 1, can get us to 5. We need all positives, so we're going to have plus 2 plus 3 to get a positive 5 and keep a positive product for 6. And so now that we have our factors, we are looking for like factors to cancel. So we have an x plus 3 in the top and the bottom. So those do reduce out because when you divide something by itself, it becomes 1. So that's reduced. And so nothing else is going to reduce here. Remember, in order to reduce, it has to be exactly the same. So the x on top is not the same as the x plus 2 on the bottom. So that is what we are left with for our simplified answer. Let's think about our next example here. Again, we need to factor top and bottom. So x and x. Factors of 5. 5 is prime, so 1 and 5 are the only options. And we want a positive 6. So both plus. X squared minus 1 in the bottom, that is your difference of squares. So remember to factor that. We square root the first. So we have x and x. Square root the second, so square root of 1 is 1. And then plus minus are our signs. And so now we look for those factors that are the same. X plus 1 and x plus 1 are going to reduce. So that leaves us with x plus 5 over x minus 1. Let's look at one more example here. All right, so we're thinking about factoring top and bottom. So if we look at the top, we have x and x. Factors of 72. There's lots of factors of 72, but notice that we want negative x in the middle, which means our numbers need to be close together. So we're going to be using 8 and 9. We want a negative x. So minus 9 plus 8 will get us negative 1. That also multiplies to negative 72. In the bottom, we also want 72 and we want 17. So in this case, we're actually going to use the same numbers, but we're going to work with our signs. We still have x and x. We still have 8 and 9. And we need to add those to get a positive 72. So plus and plus. Looking at what we have left, x plus 8 will reduce out. And so the factors that we are left with is x minus 9 over x plus 9 as our final simplified answer.